I'm Taif Rahman from Ellison. I'm the co-president and head of the DAO. This presentation will focus on the certification aspects of electric aircraft conversion.
So, along with me, I have our colleague, Harris Kaplan. He's the manager here with us and the delegate for systems. And we have Francois Riendo on the other side, who's the manager of avionics electrical and avionics electrical systems. We have Chris Beksinski, who is a collaborator, specialist in propulsion. We have Erica Halls from Upper Air, who will share her experience on her aircraft program, conversion program. Our regulators here are Paul Garner from the Atlantic region, and he waved Andy from Pacific region. Right? And where is it? Yeah. Okay. So the Piper Archer was certified in 1960 under Car 3. The Beaver, I believe, is a much older aircraft. And as we were going through the process of establishing a basis of certification, even though this change protocol doesn't exist, we did adopt it because of the new and novel aspects of the aircraft modification. Challenges of Amendment 64 coming into effect just before we started the project, the challenges of all of those new sets of performance-based rules and trying to slice and dice what applies to the modification and not the original aircraft. This is what our team will go through and then detail. As you can see, on this aircraft, obviously the structure doesn't change substantially, but we put in new energy storage system, we have new propulsion system, and major structural elements to that. So there will be aspects of that will be discussed. Erica will come and talk to.
I don't have any slides that's fitting in the PowerPoint, but I can briefly. So we have for those who weren't at the first session this morning, we took the DHC-2 Mark I piston beaver, took off the 450 horse power plant off the front, all the fuel system out, and then replaced it with a fully electric propulsion. We did equivalent power, so it's a Magni 500. You can go to the next slide, I think it shows some of that. There. That's the aircraft that's flying right now. It has a Magni 500 that's derated. Can everybody hear me? I don't know if my mic's on.
No.
Okay, there we go. It has a Magni 500, so that's capable of about 750 horsepower, but we derated it down to the 450 horsepower to minimize the impacts on the flight characteristics of the aircraft. We put in 156 kilowatt hour battery pack. We've actually had 2 different battery packs in there now. And so we can really speak to some of the implications of actually flying this thing as an experimental aircraft to see how that would impact some of the certification items, such as, in particular, LOPC was a big one. I know if you sat in on Chris's presentation earlier, he probably went into a lot of what that means at the engine cert level. At the aircraft level, though, we were able to actually test the Magni 500 and simulate an LOPC behavior on floats and determine that we actually needed, we were looking at going to a lower engine power, a Magni 350, but with LOPC we couldn't meet those requirements, and that helped define for us from a design and certification perspective, we were actually going to have to go to the larger engine.
So Chris will be talking a bit more on the aircraft level certification aspects, but what's interesting is the Harbor Air project and our project uses the same battery system currently, so we can share a lot of our experience on these two projects to share and leverage the experience that we have. So I think I'll just let you take over the unique aspects of the certification.
Okay. So the intent of this presentation is to discuss our experience with the certification of electric propulsion. Mainly, we got hit with 2 whammies. We have new and novel technology, and at the same time, anything new and novel, we have to go to the newest amendment, which just happens to be 525.18 or Amendment 64. Moving from the old prescriptive regulations that were actually the standards to the new safety goals, or the safety goals. So it becomes quite a challenge. We will not, whoops, there it is. We will not be discussing 523.18 Amendment 64. There's a presentation this afternoon by Daniel Neufeld on that in room 205, 345. We're just going to talk about our challenges and prepare you for what you will have to go through or you will have to encounter if you have to deal with new and novel at the newest amendments. So, to start off, the aircraft itself, as Taif was telling you, our aircraft, the CAE aircraft, which is a Piper Archer, the original basis was R3. For anything that was not new and novel, we discussed it all. We took advantage of the 6,000 pound exemption from CPR, and we worked forward in amendments until we could come to an agreement on which amendment we could use that addresses the adequate level of safety. For the electrical propulsion, of course, we had to go to new and novel, which drove us to Amendment 64 or 523.18. And lucky for us, the FAA had put together an implementation procedures guide. And we agreed that we should follow that because the goal here is to familiarize this approval. The CAA aircraft are located in the United States and are all registered. So this STC will have to be familiarized. The easiest way is to follow the FAA procedures from the start. So there were two documents that we followed also from the FAA. There is the forward to new regulations cross-reference table, which is based on the FAA final rule for Amendment 64. There was also an FAA ASTM to performance-based rules cross-reference map, which they also called it Part 23 accepted means of compliance based on the ASTM consensus standards. So you can see one of the biggest challenges here was that the forward to new regulations cross-reference table is a one-to-many relationship. When you pull these documents off of the FAA website, you'll see one-to-many relationship. Also, the MOC based on ASTM consensus standards. The beginning of the document starts off with all the ASTM standards. Halfway through the document, it switches around and goes from the new performance-based rule to all the ASTMs that you should be dispositioning. Again, a one-to-many relationship. So what happened with this? This is an extract from our exercise only for 23.13.37. There are 3 pages of them, and you'll see that some of these, they're either not applicable, or you're going to find that the regulation may be applicable, the new PBR is applicable, but the ASTM standard is unusable. It's not appropriate for the new technology, and that's what Chris and Francois and Erica and I have been. That's our biggest challenge to date. The rules, the standards are typically not acceptable for the new technology. So we have 3 pages of these. There are actually 31 line items just for this regulation that we had to disposition, following those tables. And Paul and I looked at it and we said, maybe we should try a bottom-up approach instead of a top-down. It would cut down on the work for sure. But this has to go to the FAA, and we said, you know what? Just to show the FAA that we did our due diligence, we dispositioned everything, let's continue with the top-down approach. So, 31 lines only for this item. Lessons learned. Typically, one line item will map word for word from the old prescriptive regulation to some paragraph in an ASTM. And the rest of them will all be superfluous. The other lines are typically not applicable, or there's some duplication. For instance, most of the regulations point to the new PBR that replaces 1309, because everything affects reliability, right? So you'd have to disposition it and say, no, we were already covering this. So be prepared. Expect that you will have to go through multiple iterations of your G1 issue paper, and even for an STC, it becomes so complicated that it is preferable to go the G1 route. You will also have multiple iterations of your cert plan as your cert basis develops. Be prepared. So our exercise for the CAE aircraft resulted in 1,356 line items like that we had to disposition, one by one. Here's something else that we learned. If one PBR is affected, the new rule, but if that PBR maps back to various old prescriptive regulations, they must all be at the same amendment. You can only show compliance to a rule at one amendment. If the PBR is going to be used at Amendment 64, then the intent of all the old prescriptive rules must be addressed at one amendment. So here, for 2615, this one mapped back to 1141, 42, 1303, 1305, 1311, 1321, 1323, 25, 27, and 1337. All of those, the intent of all of those regulations, because one of them we decided to move to 64 and show compliance at 64 because of the new and novel aspects. All of the intent of these regulations must be addressed at the newest amendment. Also, and this was a very important aspect, our delegation does not cover Amendment 523.18. It doesn't cover PBRs. So Paul and I sat down and we said, how are we going to do this? And we agreed that, well, Paul agreed that if we can show a direct relationship from the old prescriptive text to the paragraph that we're going to be using in the ASTM, and that wording is one for one, there's no question. We can propose our delegation applies. If there's any change, it is open for discussion. Am I correct, Paul?
Close enough.
Yeah. I'm going to hold you to that.
I know, that's what it seems.
So, yes, you needed agreement on this. If your DAPM doesn't already cover it, sit down and have an agreement with your OPI. A couple of other things that we found. There are very, very few standards that are appropriate for electrical propulsion. Another thing, there are even less of these standards that are actually accepted by the FAA. Another challenge that we're facing is with the change from fuel to energy, there is a discussion about who takes the lead. Fuel, hydromechanical. Flammability requirements, they were always developed by power plant, right? Except now we have batteries. Electrical have been looking at the flammability aspects of batteries for years. Maybe they should be the lead. So this discussion is ongoing. Who takes the lead now when you're using batteries as your fuel source? Up for discussion. Also, the Part 23 Implementation Procedures Guide makes it very clear that the MOCs, we're not using that term anymore. We don't want to confuse that with the new safety goals that are the definition of the PBRs, the performance-based rules. So they're using the term DDS, a detailed design specification, which become the standards. That is the standard. And they've been moved into ASTM. So the choices are this. From that document, from the Implementation Procedures Guide, we were told to either use accepted ASTM, this is in the Procedures Guide, and like we said, some of the old prescriptive regulations mapped word for word, so in those cases it was easy. Some of them we were allowed to use Amendment 63 text. Also, there is some ASTM that the text is appropriate, but it's not FAA accepted. For instance, and Chris is going to talk about this further, but ASTM 3239, the standard spec for electrical propulsion systems is not FAA accepted. It's still under discussion. Alternately, if all else fails, the applicant can propose DDS, and the implementation procedures guide suggests that we do that by issue papers, and Paul and I agreed that since there's already a process for issue papers in Canada, we may as well follow the process. Another thing that the implementation procedures guide states is that all DDS, because they are now the standards, or they're defining the standards that used to be housed in the old prescriptive regulations, they must be part of the cert basis. So the implementation procedures guide suggests that we publish this in a DDS collector's document, and all of these standards, which address the new safety goals, or the PBRs, they now become part of the cert basis, which must be listed on the certificate. So part of the cert basis we typically put at the bottom of the STCs. Now you also have to include the DDS standards as part of this, which you can include inside a document. And the best part of the implementation procedures is, where's the pointer? There it is. It includes examples in your DDS issue papers. It includes examples for your collector document. So the FAA have done quite a good job putting this together. And Transport Canada agreed that we should use this process. So, our result, our CERT plan is now over 500 pages. Our CERT plan now has, because we've broken them up into not just the paragraphs, but also the sub-paragraphs in certain cases where the intent is different. We've broken them down to 493 line items. 301 of the 493, or 61%, are at the new amendment because of the new and novel aspects. Something else that you'll find, 1301C must be installed according to limitations. It's included in a paragraph of the ASTM, but as we went through the PBRs, we couldn't find any appropriate home for it. So we proposed going back to Amendment 62 for 1301C as an add-on. Still in discussion with the authorities. So this is what we ended up with. Well, and we're at an interim stage right now. 111, or 36.9%, we've been able to use accepted ASTM with that extra proposal of 1301C. We've got 2 accepted ASTM, which required additional proposed DDS. 2 of them we used PR language. 35 of them, or 11.6%, we were able to use published ASTM that is not yet FAA accepted. 4 of them needed a little bit more. 107 of them, or 35.5%, the applicant had to propose because the standard was not appropriate for the electrical propulsion, et cetera, et cetera. So we were just discussing that current ASTMs, typically for electrical propulsion, they are not appropriate. And they're not appropriate for the novel aspects of electrical propulsion. So that requires the applicant to propose DDS via CAAM and issue papers. Some of the issues, and this is just an example, thermal runaway, energy remaining indication. So we have over a dozen custom DDS IPs, issue papers, covering different areas, which include fuel to energy, developing standards for energy that meet the intent of the old fuel tank standards or the old fuel standards. There's nothing appropriate. So this is just one of many, many aspects that was affected. These are some of the topics that we've introduced via issue papers. Let's just go through this list. I'll put it back up shortly as the specialists discuss what they had to, or what they are going through right now and proposing. Yep. Here's a list of our issue papers. So, thermal runaway, lightning strike, et cetera, I think it's probably best to bring up the specialists and let them discuss their challenges with you. And I'll just hand it over to Chris.
Thank you. First of all, I just wanted to give a quick overview of the state of readiness in terms of the entire regulatory framework. Going with Amendment 64. First of all, the PBR rule. There are very few gaps, but well, there are some issues. For example, every new hazard seems to be added to 2410, which is power plant hazard installation hazard assessment, just because it seems to be like a new bucket to use things. There's still some gaps with fire protection, 2440. We're going to talk about that. There's a lack of proper coverage at the rule level for some accessibility and maintenance. Plus, there's also, TBD issues. For example, cybersecurity, autonomy, etc. If these are required, if these are applicable, well, let's just say they're not currently anywhere in the Part 23. At the DDS level, there's significant gaps. I won't go into the accepted, what's the difference between custom and accepted DDSs. I think Harris covered that, but I will go into what the gaps are. But then we've got the level below, which is guidance. Well, there is no guidance, even for the standards that have been published, or rather published but not yet accepted. There is no guidance on how to apply them, and likewise, there is nothing on the interpretation level, because this usually comes from case precedents, some internal document and there is none of that yet. So we've got quite a lot of work to do. So I did a further comprehensive gap analysis on electrical propulsion area, and my colleagues also did their own in their respective fields. So I'm going to focus on the electric propulsion aspect first. Now, there is, however, an existing document. It's been out for a while, first published in 2018, last updated formally in 2022. That's F3239, standard specification for aircraft electric propulsion systems. Now we're using it as a sandbox for electric propulsion. Basically, we don't want to create new standards and put them into other ASTM documents, because then that might preclude the publication of that other document. So there's few Canadians in that group as well. A couple of them here with me. Now, doing a count of these requirements, there's a total 48 in the published version. Out of this total, 34 are useful for subpart B, power plant, generally speaking. 2 are useful subpart G. Some of those useful ones, like call them quotes useful, may require additional adaptation or changes. And now note that this count excludes low voltage electrical system standard. That's something that Francois can talk during the panel session when it comes to F3316. But there's also work in progress items that are not included in this count. Now, as Harry said, the FAA does not universally accept this spec. It's not that it's not accepted, it's not universally accepted, and it's actually listed in the FAA means of compliance with the following provision, that applicants may propose the spec for development of their own means of compliance, as the FAA phrased it at the time, for electric propulsion systems on a project-by-project basis, but they must be accepted by FAA. That is, the applicants' proposals have to be accepted by the FAA in accordance with the regulation. So there's quite a bit of work that was done on F3239 since its publication, and now this list is subject to change. Some recent files included addition of electric power plant cooling, also power plant indications, which did include some additional verbiage as the definition of usable energy, which actually I've made a negative on the ballot item. So basically, these ballots have failed to be published yet. There's still some work to adopt the wording, but they're ongoing. There's also some new items that we've just restarted. Fire protection requirements for aircraft propulsion system. That's something that has been on the sidelines for a while. I've just sent proposed DDS to the group last week, to a much smaller group, and we just had a telecon on this as a matter of fact yesterday. There is the implementation of single fault ratings. That's right now being talked only in a core group of 3 individuals, myself included. And for other items, there's propeller installation requirements. That's, well, it's even questionable, do we really need one? There's HVUS, which it's also TBD because FAA is not really planning to go with the HVUS. There is the definition intent to bring some related content for batteries from SAE or F39.5 that Kevin will be working on. And post-impact conditions, that's been on hold. There's also separate practices, but the basic lesson learned is applicants need to be aware of the limitations of the spec before using it in their own circuits. The only way to be aware of that is basically to engage and to actually, have an in-depth understanding of what's going on. Now, as I mentioned, having done a gap analysis, if we count at, compared to the old Part 23, if we count at the sub-paragraph level, there are 178 prescriptive regulations, or LDDSs, that are somehow affected by electrification. And that's after accounting for those usable requirements from ASTM spec that I've shown earlier. Now, 78 of these need simply revision. That's pretty straightforward thing. Can be revised wording, revised, some kind of a clear, straightforward revision. 51 need equivalence. So basically, some may say, hey, this doesn't apply to me because, I don't have this or that. But yeah, but if you're flying with the same environment and the threat comes from that environment, but the threat mechanism may differ, but the operating environment is still there. You have to somehow account for that. And 49, applicability to be decided, and that actually depends on the design of the installation itself. So most of these are for subpart E power plant, but there's other subparts that are affected. I didn't count in subpart B. That's our flight specialists are taking the lead on that. Now, the key lesson learned is the published standards are only a small fraction of what is needed. That's why we have to go the custom BDS route. Now, here's basically the distribution between the different subparts. As you can see, there's quite a few in other categories other than power plant, but for most of those, especially the difficult ones, they do come up with power plant. But you also you have to consider the fact, there's system and equipment effects, there's AFM effects, etc. There's effects on occupant safety, and even some adaptations on the structure side. So I'm not going to go through the full process. I'll let you read it. But basically, this gap analysis was done manually, line by line. No model-based system engineering used like we're trying to do with NASA. ASTM, both Part 23 and ASTM standards were considered. It's actually useful to note that ASTMs, they do have actually a one-to-one correspondence. There is actually a table in ASTM specs that shows you which PBR this given spec line item pertains to, so that helps. Basic plus leveraging experience from Part 33 work. So the basic lessons learned is here to do this gap analysis, to account for it properly, it has to be done at specialist level. It requires an insight of regulations in the domain, and interrelation with other domains, as well as some understanding of Part 33 and ESS function. So, as we talked before, custom DBSs are needed to address all these gaps. And what I've used my end is relied on published material, but with caution. There's some, like EASA and OCs for VTOLs. There's a lot of draft ASTM materials, so that's subject to individual scrutiny. There's other unpublished materials, draft FA, SFC, MOCs, IPs, etc. And basically other sources of information. So based on that, we're able to put together proposed custom DBSs to match the intent of the existing rule, in the context of electric propulsion, while maximizing the usage of existing wording where possible. Once again, it's a very in-depth technical activity, and it cannot be taken for granted. So here is an example that I've actually used this, and mind you, this is a slightly different process. This is, I would say, a bottom-up approach, like line by line, which differs slightly from what Harris has described in his bottom-up, in his top-down approach. Just a couple of quickly some examples: usable energy and usable fuel, legacy aircraft. It's fairly simple because the total capacity is invariant. Fuel tanks don't shrink over time, let's put it this way. Here we found out that some of the issues, well, first of all, we have to determine, determination of the stealth of health is fairly a subject in itself, because it has to be both accurate, but it has to be practical. You cannot simply, have to discharge the battery to ensure its full capacity. You have to have some predictive algorithm. Then another question: what's the usable energy? What's the zero in the gauge? And if you're in an abnormal operating range, where your power may be varying as a function of voltage, well, there's a proposal that has been made to use a bulk clamp gradient as an example. Then there's the question of quantifying usable energy for cockpit display. Well, on one hand, we want to be conservative. On the other, we want to maximize the energy usage, low energy indication. And the separate issues is the energy reserves, which I'm not going to get into. Now, what helps is that the FAA has draft issue papers on these subjects, which do drive the decision-making process. Interesting one is the 30-minute MCP challenge. This is actually at the PDR level. There is also a corresponding standard. The FAA has allowed an alternative of using max cruise speed instead of max continuous power when meeting this 30 minutes requirement, but this has not yet been vetted by Transport Canada. Now, the lesson learned here is that this requirement may seem easy, but when you consider the usable energy, that is the end-of-life battery as opposed to beginning of life, electrical efficiency issues, temperature, and other effects, meeting this requirement can be a challenge. And I can think of some projects, including ours, where it can easily be met with a VTOL battery, but in the end, that requirement could end up driving the effective battery life if we based our capacity on the end-of-life state. The SFR, well, given the time, we probably won't get too in-depth in this, but the basic point is that CMT has left it fairly flexible, that the climb requirements close to the ground are to exit the ground conditions to the obstacles, and you have to have the ability to climb to safe altitude. Now, the specific criteria were left to be determined with certifying authority. However, the FAA has recently started promulgating that via their own issue papers to enforce it on US applicants, and some of that is back to prescriptive requirement. Now, the issue that we're having with this is, well, it's really not a fair comparison, because what some are proposing within the FAA is basically to ensure that aircraft has a positive climb gradient above, say, 100 feet per minute threshold throughout its operating range. After, say, as in our case, are close to a 50% power loss. Well, that is not something that is either achievable nor fair if we're going to consider comparison to existing fleet, because many thermal-equipped engine aircraft are unable to climb at all at hot and high conditions after a minor power loss of 15%, which is 10 times more likely than what we're seeing with single-fold ratings and LLPC. Now, here's a climb chart, and you can see on specifically on the one to the far left, at hot and high conditions, after failure, which is the dashed line, basically with a traditional, say, level 1, level 2 aircraft, above certain altitude at high conditions, you cannot climb at all. In fact, in some cases, above, say, 7,000 feet, you will be descending. In comparison, at 50% power loss with an electric aircraft, at ISA, you can climb above 100 feet per minute, but at high altitudes, it's going to be marginal. It's going to be between that 0 and 100. But yet, at high temperature, it actually is going to be still, after 50% power loss, you'll still have better climb performance than after 15% power loss in a traditional aircraft. And that is because the electric engines do not suffer from the power lapse due to altitude. And that's okay, so there's a few more slides that justify our position. But basically, what we do want to do is, for level 1 and 2, we're proposing with CAE to use declared performance in form of watt charts rather than a prescriptive ROC over the entire envelope. And there's also probabilistic analysis that is here in the slides that supports that. Now, there's also discussions on the power plant fire withstanding zone concept, but I think for the sake of time, we may want to proceed with the panel discussion instead.
If anyone would like to discuss these issues or have any questions?
I don't know if I have a question, but maybe some thoughts in terms of the approach that we presented here. Just some background. I was the co-chair of the art committee that built for 23, the new one. So I have intimate knowledge and purposes behind it. And I'll just say that in the end, the FAA got subparty wrong. They didn't follow our recommendations, and they did something different. So this 30-minute thing that ended up in Part 23 wasn't supposed to be there. It was too prescriptive. So I think one of the things that we have to recognize when we're dealing with new and novel technology, especially today, when we're looking at electric propulsion hybrid, and potentially H2O and potentially other sources of propulsion. For us to try to go back and look at what MS62 said and the intent behind it is often going to lead us in deep rabbit holes. And it's something that the FAA has discussed already because they tried to write an ADS based upon the old paragraphs and used the same paragraph numbering and found out that it didn't work. So my suggestion would be is that we have performance-based rules, they're there. We have some of the ASTM standards in place, but we also have other pieces of information as you learn about your technology and to try to look at your technology moving forward to develop your DBS. And that's kind of what we're doing at the ASTM and SAE table is, yes, you pay attention to, what 1141 said, but if you try to do a complete mapping from Amendment 62, and then go to your new rules and then to the DBS, that I think often will go down rabbit holes where we don't need to, because the intent of a lot of the old Part 23, especially the power plants, had some very specific connotations because of how combustion engines work. We can't apply them. So I think the approach that you found a lot of good issues, and it's all great, it's gonna help us write the standards, which we're currently in the midst of and trying to get this stuff out. But I think I could see an easier way moving forward, because the intent of what we tried to do in part 23 was to ignore what it used to say and move forward. So, there you go. And just, the other thing, one other thing is, looking at what you presented, maybe we should sit down and talk about this more, because I know currently EASA is taking a very different approach on some other programs that I'm involved in, as well as the FAA, compared to what we're doing. So from a harmonization standpoint, it's probably really important to be pulling all this together amongst the authorities to say, are we all approaching it the same way instead of going in different directions?
That's a good point, Kevin, and the discussion that we've been having within ASTM, as you well know, the problem is that in the end, that's what we end up doing in ASTM, basically. Even though that wasn't the intent, the ASTM initially simply, took the prescriptive Part 23 regulations and made them a standard, right? And that's our starting point. And it was not supposed to be there. It was like that. It was supposed to, Part 23 was supposed to give the applicants the added flexibility. That was the intent of the FAA's decision, yet it didn't really come out that way. As far as the F-3239, the problem is that because of all the discussions that are ongoing within our group, applicants simply cannot afford to wait. Right? They have to write their own specs somehow. And unfortunately, most of them, those both in the US and in Europe, do not really share their own VDSs. So we actually have a situation where we can come up, the different companies can come up with different custom standards that do not match each other, or that result in a different level of safety. And that's a problem going forward.
Yeah, I just want to indicate that a number of the concerns and lessons learned that are identified, they're recognized. We'll continue to work with the applicants on those. We'll continue to work with the applicants on those challenges, concerns, lessons learned that are identified in this slide. I do want to highlight the very last one. My recommendation here has been and continued to be that joint sessions with the affected disciplines will be engineering specialists to be arranged at the appropriate times. That's the way we have always worked with the DAOs that have been explored. So my recommendations are the regional projects is, the projects that are managed by the regions. We will continue to support as we have always the multidisciplinary sessions. If it's not clear to the industry who they need to contact, pick up the phone. Call me. Call Aziz. Call Stephanie. Let's not sit back and say this is an issue. If you answer, we'll give you the answers and to talk to on those challenges. Thank you.
Would anyone like to have any questions for the specialists on any of the other issues? The little runaway, fire with standard zones? No? Then may I suggest that we adjourn and, wait.
We were recently approached by the NRC because they want to invest in research, and a couple of areas that we should take advantage of is how much research can do to improve the safety and the designs of aviation propulsion, electrical aviation propulsion. So there's something we should pay attention to. What are the resources to lead the research in order to get what are the safety lessons learned to apply in certification? Just a comment.
I'll actually mention on that one. We are working with the NRC right now. We have a project on submersion. There is no actual regulatory requirement. There's something about, not presenting hazards to the aircraft or the occupants, but it's very vague and it doesn't specifically talk about submersion. So we have a project with the NRC right now. Even if you look at the existing standards, most of them talk about taking a battery pack and submerging it. And I think it's something along the lines of, as long as it doesn't have any hazardous or catastrophic effects to people within 5 minutes. Effectively, it's allowing you to submerge this vehicle that the batteries will not kill people within 5 minutes. That's all they've really done. What we're looking at is if you submerged a fully energized system, so you have your engine is fully energized, you've got your capacitors, et cetera, other components within the inverters that are still holding charge. And the pilot might not be able to shut everything off if he's in a ditching incident. What actually happens to the occupants beyond the fact that the batteries might be gassing off or creating fire, right? There are potential electrical hazards. So we have a project with the NRC right now looking specifically at that, and also some of the DO-160 gaps. I don't think that was on the slides here, but the DO-160 really only addresses low voltage components and systems. There's a theory that, well, just because it's more voltage doesn't really mean the process changes, just maybe the tolerances or the pass-fail criteria need to move, but is there something more beyond that we're not considering? So we are looking at the NRC right now to try and support that. Not a specific, I'd say, cert item, but with the hopes of improving the overall knowledge and safety of this technology.
There's also a consideration, the electrical aspects or the battery aspects. It's typically the battery manufacturer that is responsible for that, and that's where most of the money comes from. So any efforts with NRC or testing or whatever, that's typically from the battery manufacturer, not from the STC applicant. The money's just not there from the STC applicant in most cases.
And I want to comment one broad issue that I'm seeing is really when it comes to data sharing. We've got a sizable community, we've got regulators, companies, armies of engineers, and yet companies are reluctant to share data because they feel it's proprietary, even if it's safety critical data. Product development is priority, so individual companies are not doing as much R&D work, they're not really testing as much in terms of failure mode and back demonstration testing. So fundamental research that comes from organizations like NASA, NRC is useful at this moment, but there needs to be more. In fact, the problem is that it's a very disorganized picture, and it's very siloed, and a lot of the data that is being produced is simply not shared. I was also talking with NRC, and I was surprised to find out that there is actually hardly a collaboration on some of those issues that I'm working with NASA, and yet I've got NRC 30 minutes from my house, and we're not working together. Well, something like that needs to be changed. There needs to be a closer, supportive, and collaborative network of experts.
So